I'm here with Mark from Rockwell Automation. And we're here at the FANUC UK Open House. Why do you work with FANUC, and who are Rockwell?
So Rockwell are the world's largest dedicated automation company. We do about 9 billion turnover, and we're a key partner for FANUC. So FANUC are a platinum partner, and our PLC equipment, which is the crown jewels of what we do, connects seamlessly on Ethernet IP to FANUC's robot control.
Absolutely. And when you kind of talk about an automation project, there's normally it's not just the robot that sits in the middle of everything. That is normally that's kind of the pride and joy. That looks the best. That's like the most obvious thing. There's so much more wiring, safety equipment, even just buttons for doors and stuff that goes into this thing. I'm programming the PLC. There's so much more to an automation project. Is that where you come in?
Absolutely, you've nailed it. A robot's not an island of automation, so it's all the associated things such as the functional safety that we've got here. So this shows off how our devices such as light curtains that protect people from getting injured, and our safety scanner, which shows an optical device which protects an area from someone walking in and getting injured, stops the robot in its tracks. And we're showing off here sort of things like access control, so we can open gates and doors, and how we connect sort of intelligently using these little guard link devices. So rather than wiring everything back individually, wasting a lot of time and effort, it all connects nice and
just a screw push and screw fit rather than little wiring terminals, putting crimps on the ends of wires and whatnot.
You've got it, exactly that. Exactly.
Brilliant. And safety is obviously a really important part of an automation project. Do you think sometimes it's a little bit overlooked?
Yeah, definitely. It can be like quite often like designed in after the fact. So definitely good to get it in up front, and that's where we can help as well. We do smart machine workshops, so they're free of charge. So if anyone's interested, we can help them out with that.
Absolutely, and I think like when I first saw automation, when I was kind of starting as an engineer, there are a lot of big cages and big devices keeping you away from the robots. But things are changing a little bit. You've got kind of more advanced light curtains, laser blankets, so there's no actually physical. There's nothing really physically stopping you from getting to the robot. How is safety changing over time?
Yeah, it's definitely changed. So we're seeing more and more people want an open, an open system. So optical devices or radar triggering the entry and stopping the device. Limiting fixed guards, which can be quite cumbersome and get in the way of a layout of a cell. So it's definitely moving that way.
And what are the advantages of moving to these kind of standalones, these kind of individual little systems here, rather than a big fat cage and a wall stopping people getting somewhere?
It just allows for a more flexible manufacturing opportunity, and also takes up less real estate sometimes. So, it is horses for courses. You have to weigh up the pros and cons, but there's definitely a place for fixed guarding as well as optical safety.
The fixed guarding is just a big fat fence you just stick up in the workshop, in the middle of the workshop. Obviously, it won't cost maybe as much as a light blanket, but it won't be as configurable.
Exactly, and you'd be surprised actually. A fixed guarding is actually more expensive quite often than an optical solution. But yeah, it's horses for courses for sure.
Brilliant. So if you're looking for an automation project for today, that might be for like a 10-year contract. Putting some fixed guarding in might make sense. But if you've got an automation project for a couple of years, you might want to change over the component, the style, the orientation of everything. Might actually help to invest in some of this equipment.
Absolutely, and it can also catch some residual risk as well. So things like safety scanners, even if you have a gated system, if you walk in and you're still in harm's way and a friend accidentally resets the system, that's going to prevent unexpected startup, so they can be a secondary safety function as well.
And even though people use isolation systems, padlocks and keys to isolate systems safely, sometimes those systems, those procedures that maybe aren't followed as well, it's nice to have an extra backup if people don't follow protocol, which hopefully they all are at home.
Absolutely, yeah. These devices are good at guarding like sort of the unexpected, the uninitiated, let's say. There's someone that might be cleaning the cell that's not aware of the risk.
They might be the most vulnerable as well, so it's important to keep them safe as well.
Exactly. So.
Perfect. Okay, so safety devices, very important. We can probably talk about these all day.
Yes.
Might not be the sexiest topic, but I think it's probably one of the most important topics you might be talking about at an automation open house. Moving on to something a little bit cooler. What is this? Let's set this thing going, and then you can explain to me what it is.
Yeah, sure. It's just decided to stop as usual in the live
hit
demo,
reset. We always know how live demos go.
It's up and running. But it's basically a glorified Scalextrics track. So it's an intelligent conveyor system that uses magnets to move these movers independently around the track. And what that allows for is a real flexible manufacturing approach. So if you want to take products at different speeds to different processes, this affords you a very flexible approach.
And these kind of dynamic production lines require something very different from what kind of a normal conveyor belt system can provide. Because normal conveyor belt system, it's used in probably factories up and down the country. There's one thing they don't let you do. What is it?
Yeah, so a traditional sort of conveyor belt system, which is commonly used in automation, doesn't afford you a great deal of flexibility. So this is like a glorified scalextric system. So you can see here you've got merge and divert systems. You can run the system backwards, forwards. You can speed it up, slow it down. Each one's independently controlled and safe as well. And it's got automatic anti-collision built in. So there's lots and lots of advantages for a flexible manufacturing application for this.
So again, talking about safety, this might be even safer than a motor gearbox with a chain system, chain conveyor belt, which all needs to get guarded up. This is not going to hurt your operators, hopefully, without any extra fixed guarding.
Absolutely, yeah, absolutely right. And very, very flexible. So, really can open up, opportunities for meeting throughput, meeting sort of, the manufacturing demand of one. So having a very customizable product that can be sent to different parts of the process, or even processes that aren't that well defined, where inspection tasks may require reject loops to be added or extra checks to be done. So
so it's interesting. We were talking off camera a bit more about new manufacturing processes, which are like, for example, battery assembly. We'll be seeing some more battery assembly later in the day. And these are new manufacturing processes. They're not very well defined, like you say. They're not very well known. They are unpredictable. Even though they're going into production, into proper products, they're still kind of not very well known. That's another reason you might need a system like this.
Absolutely right. Yeah, that you've hit the nail on the head. So I think if I walk you over to the other side, what I can show you is how we can de-risk expensive solutions like that in the virtual world. So we have a digital twin system called Emulate 3D, and you'll see in a minute that with the aid of virtual reality, we can actually showcase to customers what they get before they invest in it. So it's this kind of sales tool, but it also allows you to connect to real equipment to test and sort of save up to 30% commissioning effort. So Cameron here, who's our stooge, is going to don the headset.
Brilliant. Go on, Cameron, get the kit on. Let's see what happens when you actually use virtual reality to... Is this for changing current automation setups? Is it for testing existing setup?
Yeah, exactly. So you can build your virtual environment as in your factory, and then you can apply changes, add additional reject loops, additional buffering, whatever you need. And then you can try it out both in virtual reality and make changes to your PLC code before you actually physically go and do anything. So
okay, let's ask Cameron what he's doing. So Cameron, hello, I'm here. I'm not a ghost. I am actually here. So what are you actually doing right now, please? Let's keep trying it.
Okay, yeah. So what I'm following the green arrow. So I'm sorry if I'm hitting you, but what we're doing is, as Mark was saying, this is the digital twin software. So all I'm doing is entering into the interactive environment, and I'm testing out a work cell and seeing, is it laid out right? Does it react in the same way that I'm expecting? And you can have this all cooked up to your PLC code. So this could be with your 3D mechanical design and also your PLC code. So it could be an almost exact replica of your machine for a nice bit of testing of your performance.
Brilliant. Very well explained, but you do keep hitting me, I'm afraid. Is it because you can't see me or something? What's happening?
I'll stop moving.
That's all right. Don't worry about it. So if you could actually explain to us what you're looking at right now, what kind of cell is this, and what are you going to be doing? Like, let's say you wanted to reconfigure it. How would you reconfigure it?
Oh, right, yeah. So, I mean, I'll talk through how it would have been built. So this would just bring in from a mix of things that are pre-built, so things like the robots, some of the turntables, probably pre-built. You just drag and drop them in, but they're all configurable. So you can change the heights, widths, speeds, and anything like the parts that you see that I was picking up. That would just be imported from 3D CAD. So if you had new parts, you just import that from your SolidWorks, your Inventor, whatever software package you're using.
Brilliant. I can see a little folk truck driving past there as well. That's fascinating.
Probably. Yeah.
Okay, thank you very much, Cameron. Appreciated. Mark, very much appreciated as well. That's all the automation systems, digital twin, safety, and super high-tech conveyor belt from Rockwell Automation. always wanted a spork. Thank you so much for setting this demo up. These have been injection molded on a RoboShop from FANUC, and a lot of people know about RoboShop, but for those who don't, what is special about a RoboShop machine?
So RoboShop is our own injection molding machine. They're quite well known in some industries, but a lot of people don't actually know we make injection molding machines, especially kind of more the robot FANUC customers. It's one of the only CNC-driven servo CNC controlled injection molding machines on the market. And yeah, this is our exhibition at the open house.
Yeah, absolutely, you've got a fantastic demo. I love it. You're not just making sporks just for my camping endeavours, but some like knives and forks as well. We're going to talk about those products in a little bit, but first of all, take me through the actual demo itself, the chronological process of how one of these gets made.
So we are moulding on a 150-ton machine. At the start of the moulding process, we have our material feed systems. So they were very kindly supplied by Peervan for this show. So you can see there's a hopper with the material in there. It's then sucked up into the hopper on the top.
And what kind of material is it?
It's a plant-based biomaterial. So we want to demonstrate that our machine isn't just for moulding medical-grade plastics or polypropylene that are quite common in the industry, but we can mould a huge variety. So this is derived from plant waste, from agricultural waste, and it's completely home compostable. So you can put it in
compost bin, and it'll save you from sticking it in the real bin.
Yeah, trying to reduce plastic waste.
No plastic inside, but obviously medical parts still need to be made out of good, clean plastic because it's inert. It's a good material to make. What is important about making medical components in an injection molding machine?
So for us making medical parts in our injection molding machine, it's about the repeatability and the reliability. Quite commonly they'll buy a machine with the tool, they'll be paired for life, and they want that consistency through the process, which our injection molding machine is perfect at. It monitors many parameters to control that.
And you can see on the control here, there's loads of readouts, loads of those parameters that have been shown to the operator. Yeah. Is this what you think is important about a real good control system in an injection molding machine?
Yeah, so you can get a lot of data from this. One of the main things we're trying to show this year is our power consumption. So we have one of the lowest energy consumptions on the market.
And is that from the servo-electric design choices that have been made in the machine?
Yeah, the CNC servo-electric controls is just really, really good for our energy efficiency. But also we have a regenerative system on here, so when the clamp opens and closes, when it breaks with the motors, it sends that energy back into the heater bands of the screw and barrel, so it saves that energy, reducing the waste.
Almost like a high-end car. I love it. Regenerative braking almost.
Essentially, yeah, it's kind of like Kerr's kind of F1 technology in an injection molding machine.
F1 technology, so you've got the consistency for good medical parts, but also, if you follow me, let's keep going. Let's have a look at the actual mold itself. You get the consistency for medical parts, but also the energy efficiency for that every machine shop around the country is looking to save energy.
Yeah, it's key at the minute. So it's a huge variable in their molding.
In the cost, yeah, profit loss cost is very important. Let's talk about the mold next. So the hopper material comes in, this plant waste material. You've got a special mold. Is there anything special about the mold you want to talk about?
No, the mold is relatively basic for what we can do. There's no side movers, no what's it, but it's a really nice high-end mold from Formtechnic. So it's just designed to run over and over again. It's really nice.
Yeah, another technical partner, but then the interesting bit here as well.
Yeah, so one of the really cool features that we've got here is our automation. So rather than a 3-axis Cartesian, we've got a 6-axis, but to keep the height lower, we've got it on a linear rail. So a lot of our customers struggle with floor print or the molding in a clean room. This means
really tight little space over the machine. It's almost the same height as the hopper.
Yeah, so I mean, normally now, if you had a hopper dryer on the top, that would be the limiting factor. The guys over at Hi-Tech have done a really good. They've integrated a 7th axis on this linear rail, so you can pick, drop the parts. It's then laser etch them and then drop them back onto the conveyor.
I love it. So there's an extra process here, the laser etching, which now says FANUC UK Open House, very imaginative.
Yeah.
Brilliant. And so the extra laser etching process, do customers, are they starting to ask for more customized processes that are automated? Because previously this would be done with someone would take a tray of these, I guess, which you don't want to take someone to be carrying a tray of quite low value products.
Yeah. Yeah, that's what we're trying to demonstrate. The automation cannot just pick out of the tool or pick sprues and place it on a conveyor, but it can do that little bit more. and really take our operator away from the side of the machine or the side of the process to kind of do more and add more value in different areas of the business.
And what do you think the benefits are when you're looking at adding linear rails, not just an extra robot, but extra axes that are kind of custom built for an application or a machine? What are the benefits for choosing a kind of a FANUC control system, FANUC motors, FANUC drives, to adding these kind of more customized features?
It's just the seamless integration between all the technology. Yeah, it works perfectly. They communicate excellently. And yeah, you get a good end product at the end.
Yeah, that's important with FANUC control systems. All work seamlessly, controlled by FANUC controls, FANUC drives, FANUC motors, all single source. That's it. That's good injection molding practice, consistency, sustainability, and most importantly, energy efficiency.
Yeah.
Now, Carlo, we've got some amazing automation over here, which is all about box packing, palletization. Now, you represent Solent Automation. What are we looking here, and what are you proud about this machine?
This is our SolPal 2.0 solution, which is palletizer, which can palletize on both sides. So the downtime for production line is minimum, which means the time that you require to remove the pallet out and to put a new one in, reset the system, is basically a minimum.
Absolutely, and there's actually a really interesting business model, which Lindsay alluded to in one of the social posts we did yesterday. It's a rent-a-robot, which we'll be talking about in a minute. First of all, let's talk about the configuration of the machine, how it works. I mean, is this really better than someone actually just stacking a box? And I see you've got some very interesting cakes here.
Yes, so it is much better than somebody putting the boxes on a pallet, because this robot is able to do 11 cycles per minute. 11 cycles, because that means how many times a robot can come to pick the product and go over the pallet. If you, for example, have 22 cases per minute, the robot is just going to pick 2 at once. So as you can see, this robot is currently packing the right-hand side. When it finishes this side, the rise and fall doors is going to go up, which I'm going to show you in a minute.
So these doors are going to go all the way up to here on the linear rail.
Ensuring the security of operator who is going to come in and remove the pallet. From the perspective of HMI layout, is quite user-friendly, which going to tell you whatever is wrong. For example, in alarms, you're going to see what is wrong and exactly how to resolve that. Program selection is also simple.
We've got Waitrose, Kipling, Aldi mince pies, little apple pies. These all sound very tasty.
Yes, it is. You just press the required configuration, apply and load, and that's all that you need to from the machine setup. So as you can see, the change in between configuration is quite simple, because you only need 2 minutes, less than 2 minutes, to be honest.
And when you've put a lot of work into the integration and the automation, the hardware, in your opinion, what's the most important? Is it the software that makes it easy to use for the user?
Yes, software as well as layout of our cell, which comes on a chassis. So installation.
This is the chassis down here, right here?
Yes. So from the perspective on installation, you just pick it up with forklift, place it.
The whole thing can get picked up with one forklift?
Yes. You install it and just plug into electricity and air. And
I mean, would you have to screw it down? Could you leave it standing?
Yeah, you can. You need to screw it down, but at this speed, it's safe to use it.
I'm sure FANUC didn't want you drilling into their holes just for a 3-day open house.
Yes, they did not even mention that they wanted, so I just presume that they don't want it. So also, if we can go around.
Yeah, let's go around. Yeah, I'm following you, Carlo. You can take me around your beautiful product. I can just say this isn't just for tasty, tasty cakes. It's a little bit more interesting when we've got some festive bake rolls, festive fancies, and some, I think, some mince pies as well.
Yeah. This product can handle trays, bags, and boxes. So depending on what's the requirement for your factory, we can pick it up and place it on a pallet.
Absolutely. And so you mentioned at the start of this video that it's, in your opinion, it's better than a single person packing a pallet manually. Why is that?
For example, mostly health and safety, and it is, So it's health and safety. Maybe box doesn't feel heavy because it's 1.5 kilos, but if you repeatedly do the job, you're in a day you're able to
lifting a lot of weight over those whole 8 hours. Even if they're just cakes and they're not there's not too much to them, they're nice and light and fluffy. It's still a lot of strain and weight on your operators and on your staff. Let's move on to, I guess, when it comes to sizing out kind of the economics of this product. You'd be looking at it compared to, I guess, someone manually doing it. You pay them hourly. It's interesting. Most of the time, you'd buy this and it's a flat rate. But there's a really interesting business model associated with Solent Automation and this box packer. What is that business model?
This is our rent-a-robot business model, where you can rent a robot for the per hour, depending on how many hours you need. So, for example, if you work one shift, you have price different than if you are working 2 shifts or even 3. For us, if you are working for 3 shifts, if your production is 3 shifts, then we are giving you 3rd shift for free.
Okay, interesting. We can't go, obviously, let's not go into like the absolute details of the calculations, too hard to do in our heads. But what would you say is the kind of overall benefit for someone being able to pay for this almost hourly versus paying for it outright or putting it on finance?
Yes, so for renting a robot, you don't need CapEx. It's just as you would hire the person to do the job. So we envision that model to work like agency for people. So sometimes you don't need it 2 years in a row, maybe 1 year. You just need to finish one project. So we are able to cover you for time 6, 12, or 24 months. Also, we can with our machine you get 5 different pallet configuration, which is more than enough to cover these jobs. If you require extra, then we can sort that out in a day. And I mean, it's at extra cost, but you are able to palletize mostly in a day.
Brilliant. So I guess if you were to have a short contract, you say you can take it on for 6 months, then you can take it out with a forklift again because it's just one forklift, no installation, no commissioning, it's just plug it into power.
And one thing to point out, no maintenance cost, because all maintenance are going to be done by us. So the only cost with running the machine is consumables and wear and tear equipment.
Okay, so forklift loaded, one installation, no maintenance costs, rent a robot. That's a fascinating business model. I wish you best of luck, Carlo. If you're interested in renting a robot, get in touch with Carlo at Solent Automation. They've got a website. It is solent-automation.co.uk. Now, this is a neat little product solving quite a messy problem, isn't it, Adam? I'm here with Electro Impact, and this is a really fascinating process. We don't see very much of it. We've not seen this before, I don't think, at the FANUC Open House. What process are you automating?
So this is an aerospace drilling application. It's taking an industry-standard drilling end effector that's normally a manual process and fitting it on the end of a FANUC cobot. The idea being that it will potentially free up an operator to do other tasks alongside, maybe for fastening or for cleaning or whatever else needs to be. So that makes it a parallel task.
And we're talking about fuselages in aeroplanes, big kind of wing components, big kind of, it's the skin of the aeroplane that needs all those drill holes put in for riveting or for fastening in some way. And how does that normally, how are those holes for rivets normally put in like a fuselage or a piece of skin on a wing?
So this system will be quite common in places like Airbus or GKN, maybe Boeing.
And you've got some work orders here just to show the process.
Yeah, so this will be a typical kind of work order that you might have in a production environment where the operator will go to a drill jig. So if you look at the drill jig at the back of the cell over there, that's a representative drill jig that you would have maybe on a wing skin or on part of an aircraft wing.
Yeah, you can see actually it's a wing component. That's part of the aerofoil right there. That would go inside.
Again, that's just a representative drill jig. So that might be a drill jig for the front of a wing, for the nose. And then the flat drill jig that you can see there might be representative of like the flatter part of the wing along the wing skin.
You know a lot more about this than me. It's quite a complex process.
It is, yeah, and there'll be lots of these as well. So if you ever get the chance to go to a wing factory, you might see hundreds of these drill jigs.
I should be so lucky.
Okay, we'll invite you, that's fine. You'll have hundreds of these. And you can imagine the amount of labour that's required and all the amount of equipment that's required to go with them as well. So that's where we're coming in with this system where maybe eventually one operator might be able to operate 2 or 3 of these in parallel.
So you've got an operator who can come and drag this whole assembly, this whole product, over to your part of your wing on your airplane, and then what happens?
So if you go around to the front of the system, you can see a little QR code.
Put the work orders down. We don't want those anymore. They're old hat, apparently.
Let me just show you how it works. If you go to the very front of the system here on the floor, you can see a little QR code. So the idea of this is that you would wheel it up to a station, and that QR code would say, right, I'm in station number 5 or whatever it is. Fantastic. I'm expecting to see this drill jig. So once we know where we are on the station, we can come back to the operator screen.
Yeah, and I've noticed there's a few little kind of posts here that sit it down in the floor, right?
Yeah, that's right. They're pneumatic posts, so that makes sure that...
And you have to press a button.
They should already be activated, I think. But let's see how we go. Those 3 feet will make sure it's stable as it's drilling, so we don't want it moving around, obviously. So going back to the work order, the operator would have something similar to this. And we've tried to replicate a kind of simple process where the operator would be given a task, he would come along, pick up a scanner, start a new work order. As you can see, the feet, so these 3 arrows represent where the feet are, so we need to deploy the 3 feet.
Okay, so we hit the button there, deploy the feet. Yep. Oh, we lift the block up off the whole product off the casters.
Yep, everything's green, good to go. Then we're on the next screen, so we're ready to scan the work order now.
Oh, brilliant. No typing in of numbers, just a little scan.
Nope, no typing if you watch. All done.
Brilliant. So we pull all the data out. I guess it's either embedded in QR code or gets pulled from a database or something like that.
Exactly that. So it pulls in the data that the operator needs for that drill jig. So that will also load the robot program as well, which obviously we need for the whole pattern.
Perfect. And then what happens? I guess can I click confirm?
Yeah, of course you can. Yeah.
Perfect. So hit confirm. Station resync check. So it's doing some checks on the products.
Yeah. Station resync is what you've just seen, the QR code on the floor. So we've checked it. It's where we're supposed to be.
Is that because you've got a camera here that's checking the QR code there?
No, that's the smaller camera that's right on the base that we just saw before there, yeah.
So you've got another camera down here. And then what's going to happen next?
Okay, so we're good to go now. So the next thing we need to do, we need to find out where the drill jig is in space. So if you look at the drill jig, you might be able to see 3 little targets on it.
Tiny little targets there.
Yeah. So the camera on the end effector is going to go and find those targets, and then it'll know where the drill jig is in relative to itself then.
Okay, brilliant.
So,
and that's checking it now, so ready to go?
Ready to go, yep.
Okay, so you press the blue button, press the green button, and then the camera's... Wow, Andy, we're here in the huge FANUC UK workshop. There's 3 FANUC robot drills we're talking about today, and they've got some slight...
where the drill jig is in relative to itself then.
Brilliant.
So, yeah,
And that's
ready.
checking it now, so ready to go?
Ready to go, yep.
So you press the blue button, press the green button, and then the camera's going to go in. And this is because we've got two different end effectors.
So the camera's permanently fixed. So what we're going to do, we're going to pick up the drill anyway, because we want to represent what the payload is going to be when we do the resync.
Accuse me of not having enough confidence in you, but I thought it was going to crash then. I thought that was going to be like a camera crashing into the end effector. And this has got all the business, all the interesting components that help you drill a hole, right?
Yeah, and the key thing about that is a standard product. So this is a standard product that's made by a company called Lubring. And so it's a qualified process. So like I said, companies like Airbus or GKN or similar aerospace companies, they already understand that product, they already have them, they know how to maintain them, they're already qualified for drilling holes in aircraft.
So normally this Lubring product would be used, we have a handle on it just to be held by a human being.
Yeah, exactly that. So it would look almost identical, and the operator would pick it up off a trolley, put it into the relevant hole, and it would lock itself, and then they would drill the hole.
So that controls the process in terms of feeds and speeds and in terms of concentricity in that jig.
Yep, that's all done internally with a separate control system, like I said, which is already a qualified process. So we don't have to worry about the quality of the hole. That's already taken.
As long as the robot offers it up to the jig hole in the right way.
Yeah, exactly that, yep.
Perfect. So we've checked how square we are to the jig itself now. What's next?
Yeah, so we've done the resync. We know where we are, so we're ready to go to the first hole now. So before we go to the first hole, just to explain why we're using a cobot. There are three main advantages, but the main advantage why we chose the cobot is that it has internal force feedback, and that internal force feedback allows us to essentially mimic what the operator would do and wiggle itself into the hole, which sounds like a rather crude way of saying it, but it's a very tight tolerance hole. So if you use a standard robot without the force feedback, it wouldn't go in, basically.
Yeah, exactly. So you only get the cobots for free. You have to add it extra on an industrial robot.
Yeah, exactly. It's already built in. Yeah, that's
one case where a cobot actually is probably preferable over an industrial.
Yeah, and the second advantage really is if you're an integrator, you don't really want to be spending much money on this kind of system. This whole system runs off one single-phase 3-pin plug.
Really? 240 volt,
Yep.
13 amp.
That black plug you can see at the back over there, everything runs off that.
That is crazy. I'd have thought 3-phase. I'd have thought 400 volt, whatever 3-phase is.
Single phase.
Okay. So not much integration, not much extra infrastructure needed in your factory.
Yeah, which is a good thing, and that's the kind of market we're aiming at. So our potential customer will already have the drill jigs, already invested into the actual hardware. They don't want to be spending a lot of money doing foundation work or adding in extra facilities like 3-phase. They want to spend at least the minimum that they can.
Absolutely. Minimum viable investment is one of these. Try it out.
Yep.
Probably can't be that much for a big aerospace company. What's happening next?
So now it's waiting now. It's waiting for us to confirm that we're good to go.
Okay, I'm pretty good. I'm pretty happy. So blue, green, let's go. And then we start drilling.
Yep.
There's also, what I find interesting, there's also a bit of a digital little secret recipe here on the screen over there. What's happening? Yeah, so let's go have a look at the digital twin, which is absolutely fascinating. While we're watching the robot do its thing over there on the jig, hopefully drilling some good holes, you've got a big screen here that's showing something interesting, haven't you?
Yeah, so this is a live digital twin of the whole cell. So this is taking live feedback from the robot position, but it's also taking process information. So you can see we know what aircraft we're drilling, we know the ID of the drill jig, we know how many holes we've done.
So you're taking info from the ADU control system, the PC and the ADU, and also from the actual FANUC control.
Exactly that, yeah. So we've got a PLC running the whole system inside. So we pull in data from the PLC, from the ADU, and from the robot as well. And then you can see we can also color code the holes as we go to kind of indicate the status of each hole, whether it's passed, whether it's failed, whether it needs doing again, whether you need to skip it.
That's amazing. I'm going to be honest, Adam, it's very impressive. What are the benefits?
So the benefits is multiple, really. This might be sat in a line manager's office. So if you can imagine 3 or 4 of these running at the same time, a line manager might be able to view 3 of them at the same time from his office without having to go on the shop floor.
It's annoying when you buy all this really expensive equipment and you have to go and watch it to make sure it's running.
Yeah, exactly that. But it also gives the operator that might not be stood next to the robot. They might be stood nearby doing some different operations. They can maybe have a quick glance at the digital twin, see what's going on, make sure there's no problem, no errors.
Perfect. Okay, I love it. So digital twin and also a qualified process, but on the end of a robot rather than the end of a human. So it's consistent, leaving the human to do probably more interesting jobs, more useful jobs. That's Electro Impact, the ADU bot from Electro Impact here at the FANUC UK Open House. We're here in the huge FANUC UK workshop. There's 3 FANUC robodrills we're talking about today, and they've got some slightly different things, some interesting additions. What are they?
Yeah, we've tried really hard this year to try and make our robodrill offering us appealing to a wide variety of users and customers. So we've got a 3, a 4 and a 5-axis machine laid out in that order with some interesting technology on all 3 of the machines.
Brilliant. You're assuming I can count past 3 there, I'm afraid. And I'll try to. We're starting here on the 3. That probably gives us an opportunity to talk about the robodrill platform as a whole. Now, it's an interesting machine, isn't it?
Yeah, it's a brilliant platform. We've got such a great product in the FANUC robodrill. There's over 300,000 machines in use worldwide, spanning over a 50-year production. So this machine's sorted. It's been developed over that 50 years to become a really, really capable vertical machining centre.
Yeah, and it's such a reliable machine, having been designed and built for so many years. You've kind of worked out every possible little kink in a production process. This machine is so stable.
Yeah, we love to tell our customers, and we get regular feedback from customers saying it's the most reliable piece of equipment in their workshop. Mean time between failure, 7-8 years. So it is just such a stable platform for people wanting to keep the spindle running on their machines, which at the end of the day is what makes people money. This is definitely the machine to do that. Absolutely,
it's a workhorse. Now, for people interested in a robodrill who's maybe not looked at one before as an option, they are BT30,
yep.
As standard, BBT, so face and taper. What are the other options available?
So the base machine comes in 3 different sizes. This different sizes basically denotes the x-axis stroke. So small, medium, large. Small having a 300mm x-axis travel. The medium having a 500, large having 700. This particular machine we stood next to now is the medium machine.
D21M medium.
Medium, with the plus denomination after it, dictating it's the latest model. It's the plus machine with the 31IB5 plus control, which in itself has a lot of extra additions to it.
Yeah, what I find interesting is these controls, if it says B5, that means it's 5-axis capable, right?
Yeah, 5-axis capable. So we have what we call a pipeline spec of machines coming through from Japan into Europe. With a very common configuration, and they're all 5-axis capable machines. So with very little effort, we can retrofit a 5-axis table or a 4-axis table to these machines.
It's nice to have these machines come as standard, so you don't need to muck about with controls, add extra drives, extra amplifiers. It starts getting complicated and messy when you start changing those parameters.
It kind of does, but we've got those retrofits down to a fine art now. We're doing it regularly for customers, both as a retrofit and as a new machine. We offer a 4-axis table ourselves, which we'll see later on the next machine. And we also offer packages or kits, shall we say, to integrate 5-axis tables from a variety of manufacturers.
Don't get ahead of yourself, Andy. We'll be talking about that later. Moving on to the left-hand side is something very interesting. We've got a standard RoboDrill, but with some automation. Now, we've got a FANUC arm automating a 0-point vise. Why would you do this? Why would you use a FANUC machine with a FANUC robot? Does that help with integration?
It does. I mean, there's that sort of plug-and-play element to integrating a FANUC robot with a RoboDrill. There are lots of functions on the RoboDrill that we can use. Robot Interface 2 is quite a nice function with regards to operating the robot from the RoboDrill. This particular interface is custom. It's very, very simple. And this automation solution, the Tuscan RC12 from YMT, is a really, really neat solution for those with... I'd say it's really applicable to people with a high mix, low volume workpiece content. So we've got
wide blocks, tall blocks, loads of different kinds of components.
48 pallets. The robot's taught to each of those 48 positions, and those positions can be called from the CNC program. It's a really simple solution for those that are perhaps a little bit apprehensive about automation.
And there's lots of machine tending solutions. For those who are a little bit overwhelmed by the options, could you give us a little quick rundown?
Yeah, I mean, FANUC is a global automation supplier, isn't it? We can cater for people wanting multi-machine RoboDrill systems with robots on rails, or indeed something like this, which is a very, very simple solution for those that are perhaps just dipping their toe into automation.
So the best thing to do is to try it on like a minimum viable process. Get that running, get that making money, get that viable to prove that automation works, then try and roll it out across your shop floor slowly. Taking us on, RoboDrill 1, 3-axis, RoboDrill 2, 4-axis. So what are we looking at inside here, please, Andy?
So we've got a 4-axis capable RoboDrill on here. It's a long bed model, so 700mm X-axis stroke. The trunnion assembly, the 4th axis, is a FANUC's own DDR-T IB, which DDR-T being trunnion. FANUC's own DD motor and own indexer, so again, plug-and-play functionality.
DD meaning direct drive. What does that mean?
Direct drive. So there's no gearing or worm and wheel mechanism in the 4th axis indexer itself. So actuation speeds and rotation speeds are really, really quick. So it matches the highly dynamic nature of the RoboDrill itself. So basically, the 4th axis can keep up with the movement of the machine and be ready in position as the machine's for tool changing. There's
no point in adding extra axis if it's going to be your other 3 or 3 axis are going to be waiting for it.
No, and that's the reason why FANUC developed the DDR indexer itself, because there was no other 4th axis indexer available on the market to be able to keep up with the speed of the machine. So the machine would be into position, ready to machine a feature before the 4th axis had got itself ready in the next angle. So we developed our own.
Made it yourself. Brilliant. And why would someone use a trunnion who's generally thinking, well, a 3-axis machine is good enough for me, it's fast, I can get one part in, one part out. Why would you stick a trunnion on a working machine?
Reason being that you can fit more parts in there and access more faces to machine more parts in one operation. Tolerances are getting tighter, features are getting more tricky to machine. If you can machine those features in one setup, on a trunnion, then that's great. We can even drill features from underneath through the fixture. So that's an added advantage for everyone.
So accessing different sizes is really important. And also, if you've got a fast machine, the cycle times are generally quite quick. If you extend those cycle times by making more parts, might free up operators to run other machines as well.
Yeah, for sure. I mean, we like to, it does have that advantage. We can mount cubes on there so we can have the same part on multiple faces. Load the trunnion up, let that machine go for however long that cycle takes, maybe an hour, 2 hours, maybe. It frees the operator up to do more things.
Brilliant. And for someone shouting at the screen right now saying, I've got a long bed model, but I've not got a trunnion, can I retrofit?
Absolutely, yeah, very simple retrofit.
Very simple retrofit, just like simple automation as well. Let's keep going. We've got 3 RoboDrills to get through in 10 minutes. It's quite tough. We've gone 3, 4. What's next? I can't count.
5. Yeah. We've got a 5. So this machine is a really, really interesting one for us. It's got a 5-axis table on from Nikon. Very, very new development. It's a DD201, so a direct drive again, but it's a HSR variant, high-speed rotary. So this is something that's really new. This is the second table that Nikon have made.
And look at that. I mean, that is so new. Look, it's turning on a rotary table, on a RoboDrill.
Yeah, we're really excited about this development. The advent of the Plus machine has brought so many advantages to RoboDrill users, one of which is the turning feature.
Absolutely. And you said to me off camera, actually, Andy, this is probably the first time this has happened on Saturday in the UK.
Yeah, we set this up last week. We took delivery of the machine on Tuesday, integrated it over a couple of days, and I took the first cuts on Saturday morning to prove this out, and it's performing really well. We've got sort of Charles Corker, who had a lot to do with this table, helped us out immensely. We've got Mark 1 tool changer in there, so we've got the ability to be able to tool change turning tools as well as milling tools. So it makes it a true multitasking machine.
Absolutely. My first question is, why are you working on a Saturday? Second question is, why would you want to turn on a milling machine like this?
I think some components we see frequently have got a lot of features that are suitable for a robo drill. And then we find that one quite large multi-diameter bore with blends and radius on there, maybe a die-cast pump body, something like that, where we say have to put in a rather large reamer, PCD multi-boring tool, perhaps.
And an expensive tool, really expensive.
Yeah, expensive tool, large diameter, a lot of torque to drive it. So maybe we're using the 24,000 RPM spindle to machine the rest of the features really quickly, but we've got this large tool in there that could really do with some more rigidity.
Yeah, you might be using, there's two different spindle types, a high-speed spindle type, it's not quite, can't handle the heavy cuts.
Exactly, so we want to be able to machine all the small features really, really dynamically using the 24K spindle, put the turning tool, a couple of boring bars in there, and just turn those bores or bore the component out using a turning strategy rather than a simple boring head.
Okay, turning strategy, and can you program that on the control?
You can. It's got CAN cycles, your G70 series cycles that you would use on any CNC lathe. Constant surface speed. It's got all those features that you would expect to find on a CNC lathe, but we've got it on the Robodrill.
Can't believe that. Robodrill turning, first time as of Saturday with Andy. Very well done. And Charles Corker and everybody else at Nikon and FANUC. Brilliant. So that's turning a Robodrill, 4th axis trunnion retrofittable, easy retrofittable automation as well on the 3 axis FANUC Robodrill. Can't get better than that. Can't tell at all, I'm 9th on this leaderboard. I'm very upset. Amy beat me very recently off camera, and we're here at F1 in Schools stand in the FANUC Open House. Amy, what is F1 in Schools?
So F1 in Schools is a STEM challenge for children aged 9 to 19. We've got different levels going from primary class all the way up to professional class, which is your 19-year-olds. Primary, we've got 9 to 11, so the kids can make like little cars. And we get sent the outlines from F1 teams, so they can make proper F1 teams cars.
These are actually making real examples.
Yeah,
These are people of 9 to 11 years old. There's a real age range to the F1 in Schools system.
Yeah, so they've got all sorts to do. So as many just making cars like this. We've got the new Halo system for this year, but all rules and regulated car. That's our professional class car. But they can start from primary all the way up to professional. We've got our enterprise portfolios, design and engineering, project management, sponsorship and marketing. So it's not just about designing a car.
And those are all the modules that someone will do when they're working through the F1 in Schools division.
Yeah. So this is our like world finals standard of work, but we start all the way from regional level, which we're doing at the moment. We're on the road doing regionals up and down the country. That's just like in your classroom and things like that. Then if you get through regionals, you go to nationals. which is going to take place next year, and that's like our top countries teams. Then go to World Finals, so we've just come back from Singapore, which is the video in the background here.
Yeah, and this is absolutely amazing, this video showing the partying happening, but also the really important engineering going on. Yeah. Singapore looked amazing, and how was that? I'm sorry to derail, but how was Singapore?
It was insane. It's so good. The kids absolutely love it, and they just get once-in-a-lifetime opportunities. We've got paddock passes, we've got tours in the garages, industry professionals coming in and talking to the kids. It really is just once in a lifetime. And
I wish I was 19 again. I could meet David Coulthard.
Yeah, we met everyone. So many people.
Everyone, literally everyone.
Literally everyone, every single person. Yeah.
Sounds pretty good. So if you get through all these, you get to the finals. Yeah. But what's important, I guess, is for parents watching the live stream, maybe of kids who are they're interested in STEM. How do they get involved?
So head to the website f1inschools.co.uk. We've got registration links. There's my email address on there. There's my colleague's email address on there. Send us an email. Sign your school up. If your school's not involved, you can do it from home. That's not a problem. You've just got to figure it out outside of school. But yeah, it's perfect for everyone, really. Like girls, boys. We've got such a dynamic mix of people, and it's mainly like 60% boys, 40% girls. So we really are getting there with the 50-50. Like,
it's nice to try and get a balance in the gender equality, which is we're struggling still engineering even to this day.
Yeah, we've got so many girls-only teams, even on here. So many girls-only teams, and we've got a Women in Motorsport award as well at the World Finals. So we really are pushing to get women in STEM.
Absolutely brilliant. And what else do you think the benefits are for students who are moving into STEM? How important is STEM in people's careers, even if they maybe don't want to move into a job like that, but to gain kind of an appreciation for those skills?
Well, even in obviously you've got your design and engineering and things like that, we also do a verbal presentation, so it's more the confidence to stand up in front of people, industry professionals. It's really skills that they can take even outside of STEM jobs in the future. So it really does help in every aspect, and they all say that as well when they compete. So
yeah, absolutely, a logical mind, but a logical mind that can kind of explain a reason for doing something is probably a skill everyone should have, really.
Yeah, and they're so good. I mean, even like our primary kids, 9 years old, stand up in front of a room full of professionals and just be so confident with it. And they do all sorts. They perform, sing and dance. Like it literally isn't just about making a car. It's everything, and it's so much fun for them.
Absolutely, and we've got a demo here or a challenge, which I'm not excited to do again because I lost the first time. Shall we have a quick go?
Lucky, yeah, let's.
Second time lucky. You sure you're gonna let me win this time?
No, definitely not.
Oh my God! Not that it's a competition, clearly. Right? Am I lane one this time? Okay, lane one, ready to go. Roman reaction time. So, if anyone's not watched the F1, the lights go up. I didn't realise this. You have no idea when the lights are going to go black. I've got to actually think about this now. Oh no! Again! I was talking. To be fair, surely I get a third time. Amy wins for a second time. Roman's not upset at all. Whatever. Okay, thanks, Amy.
No
thanks for your time. Really appreciate it. Thanks for beating me as well. Trying to hide this machine from you. It's very exciting, though. We've got a very special demo to show you from Caris here. Before he shows you the demo, this is like a cyber automation system from Cyberworld. Yeah. But welding is quite a hard process to run correctly, isn't it, Caris? Why is it hard?
It's a hard process because it's a dark art. It's very niche, and it takes a lot of skill and a lot of time and experience to get used to it.
So it's kind of two parts to that. There's like the parameters you set and the movements you make.
Yeah, and it's all in what sort of angle that you're welding in and what material you're welding it. It all varies. So it's a very bespoke skill, and it's all about experience, really. The more you do it and the more jobs that you work on, the better you'll get.
So if you've got a year experience, you might not be as good a welder as if you had 10 years experience.
Yeah, I mean, if you have got no experience whatsoever, then you'll struggle. But it's quite easy to pick up. But then when you feel like you've got a bit further on and more skilled, you'll very quickly realise you don't know as much as you do.
All of the Dunning-Kruger effect. So the robot here, it looks like you're trying to automate. What you've just said is all about human experience. Now, how do those two things work together?
Essentially, the robot is the tool. So the robot has to work with the human. The human's got the skill. Obviously, the robot, and we dress it all out, but the human needs to apply their skill and their knowledge to the robot. So really, what we're trying to do here is allow the human to apply the skills to the robot and the robot to carry them out so that the humans don't have to do them.
Absolutely. And so there's two parts to the welding process, the parameters. Yeah. Where do they get set? How does that get chosen?
So basically,
I just hit you in the face with the mic there. Sorry, Kerry.
So this is your weld set. So this is where the power source, this is where everything comes out of. This will produce all your welds. So it's not specific to this weld set. You can use anything you want. The FANUC robot will collaborate with any weld set that's possible.
So if someone prefers a slightly different welder...
Yeah, exactly. You can use it. And you just integrate it in.
Yeah. And you still have to turn these dials, set your volts, set your amps. I'm not a welder. I've got no idea how it works.
So this is actually one of their brand new ones. So you can set your mode. You can set whether you're using TIG or whether you're using MMA, which is basically standard 1 MIG. So you can set it different ways there. So
this looks fancier than read out on my car.
Yeah. It is quite fancy. Set you back a bit, but it does the job and it will last for years.
So the human is setting the parameters here, MIG, TIG, whatever you need to get a good weld seam. There's also another secret part of it, which is actually how you do it. I've tried the electronic tester weld things. I got a very low score on those ones. So that's actually another important thing is what you do with this end, right?
Yeah, of course. Yeah, I mean, obviously the collaborative robot. The whole point is to make it a lot easier to program and a lot easier to understand how to use it. It's a lot better than the industrial side of things because you need to properly have training. Whereas this, I always find someone can start using it and figure out how to program it pretty quickly. You don't need vast amounts of robot knowledge.
Okay, so I don't believe you, so I want you to show me it in real life. Let's show me a demo now, Karis. So you've got kind of an iPad-looking thing here. You've got the cobot here. What are the components?
So essentially, the only components that you need are your pendant screen here, which is where the robot saves all its data, and obviously the robot itself. So essentially all you have is a dead man switch. So as soon as you put the dead man switch on, it will let you move the robot. It's as simple as that. So you can bring it to whatever angle that you want it to, and obviously this is where you get your knowledge from. I know doing this sort of weld application, this is the sort of angle that you need to do.
We're talking primarily, it's not a robot programmer who's setting the weld points, it's a welder.
Yeah, exactly. Yeah, so this is where it gets a bit confusing for some companies. You do need a welder to be able to use the robot, because without the welder, you're not going to get good welds. It's as simple as that, really.
You still have to capture those years and years of experience and knowledge.
Yeah. So sometimes we set it up for the customers because we've got that welding experience, and then they can run with it then. So if essentially all you have to do now is with one of the icons, you just drag it into that zone, and then it saved that point.
It's as simple as drag and drop. So it's like a timeline. We start with this point.
Yeah, so you can
then
see.
Then we go somewhere else. So if you go somewhere else,
that's where you are now. Yeah. So if I just go down here, ever so slightly, and then all you do is drag and drop,
Perfect. You're reaching
then,
over here. It's a little bit of a struggle. With
Yeah,
the
yeah,
cameras
yeah.
And microphones and me getting in the way.
And then we could just move it over here. And then drag and drop.
So is these like linear versus non-linear moves?
Yeah,
or?
so you have linear and then you have joint moves.
Okay.
So the joint moves will move all the axes, and the linear is just moving in the X, Y, Z plane, essentially. So
one more
One
non-linear move?
yeah, and then we'll do one more linear move.
Perfect. And I assume these are very well calibrated weld points you've just done there with
Yeah,
your
so
2 seconds.
So literally that will literally take you, well, as you can see, it takes 2 seconds to program. So to get a
I'm
base,
sure a real welder might take a bit more care than that, though.
well, yeah, well, it depends who's programming it.
If they're good, they're probably quite quick, actually. I mean, I don't know. You might be a great welder. I've got no idea.
Yeah. So if we demonstrate, I can demonstrate it running now.
Please, show, yeah.
So if I just take it to a safe space.
So that's like your safety plane just out of the way.
Yeah.
So it's not going to collide with anything. There's actually a really interesting case study we can discuss. Once you've pressed the, hopefully we all know how well live demos work, which is sometimes not very well, but we've got press run. And then, yes, the machine's moving. So it's going to your teach points.
So this is essentially what I've just taught. So very quickly you can get a base programming and the robot will run. Obviously we've got it limited at the moment. You can speed it up to however you want. And then you can also shift it, so you can also copy it. So if you had a bunch of parts all in a different row, you could take that same program and shift it by 100 mil, 200 mil. So without actually programming it yourself, it will do it all based off the original program you've made. So that's the great thing. It's unreal.
It's almost like a coordinate playground, where rather than doing it once right, you're like, that was amazing, now I've got to do it again, the exact same.
Exactly.
You can do it amazing once, and then you can just let it run and do the rest of them.
That's literally it.
You've got a case study you mentioned about a customer that has one of these. So they bought 5 of these. Could you tell the story?
Yeah, so basically, we had a customer come to us and they basically had a reduced amount of welders. A lot of their guys got really old and they've had a few people leave. So we're
all getting really old, aren't we?
They only had a few skilled guys. I think there was only 2 or 3 welders. So they had a large scale amount of work, need robots, need automation, need help, basically. So we supplied them 5 of these systems and then showed the welder, and he basically programmed all of his jobs, and they got someone unskilled who was an operator who doesn't have any welding experience, and they just run all 5 robots. They get perfect welds because it's trained by the welder. That's the main point.
You're utilising that one person with those years and years of experience, and then you've got other robots that can capture that knowledge and experience.
Exactly. The robot does all the work that you don't have to do, technically. And we, as long as the welder's willing to work with the robot and use it as a tool and not think, oh, it's trying to take my job or stuff like that, it's a brilliant tool, and it will always shine in automation.
Perfect. Thank you, Gary. So we've got to speed up a little bit because we've not got that much time left. Other options? There's one more option over there.
Yeah,
What's that for?
so
Let's not have a look. Let's just tell me about it from here.
So the other option is the large cobot, which has a higher payload and a bigger reach. It goes from up to 2 meter reach, I believe. So
big parts.
Yeah, massive parts, and we just use them on chassis and stuff like that. So,
brilliant. And what's special about the Cyberweld system itself? I know you guys are built in the UK, right?
Yeah, so we're a UK-based company, and we give constant support, after-sales support. The customer's the main supply. So we've got customers that we've worked with over 10 years. We go in there, help them with old systems, which is obviously a massive plus point.
It's great to have that service.
Customers don't want to be left in the lurch, especially with stuff that's brand new to them. They want that constant support and guidance. So,
definitely. Thank you, Karis, and thank you for having the confidence to show us a live demo on the stream. Thank you for watching the live stream from FANUC Open House. That's been day 1.